Are we ready, guys?
Clearly. Have I showed you? You have.
Sometimes you get plus zeros. I just drew at the sign here.
Okay.
No! I definitely never had that.
All right, that's sine.
Yeah, give me
Good start, guys.
another great start.
Woo! Remember something.
No.
I know how to do that.
Step one. Done. Okay. Derivative. What happens? How do you start this? Like, what do you think about? What do you look at? Maximum and minimum. So where this first sine curve has a max or min, what does your first derivative have? Yeah. So I know that's there, and that is there. Okay. It looks like we've got increasing slope to that first maximum, right? So that means my curve is going to be above the x-axis, and then decreasing slope all the way to 3 pi over 2. Oops, I went way too far. And then increasing slope. Are we noticing something? What does it look like? Cosine. Let's see.
It's actually
Still not real. Okay. All right. For second derivative, you can either think about the whole concavity and inflection point, or you could just do the first derivative of the first derivative. So where that has a max or min, what does your second derivative have? Yeah, so are we okay with at 0, at pi, and at 2 pi, we're going to have x-intercepts? But then the red graph, do you see how it's decreasing all the way to pi? So where is my graph going to be? Will it be above or below the x-axis? Below. Oh, we see it. So negative. Whoa. You could keep going, but I'm kind of running out of room on my graph. So. Yeah. We'll stop there with the sine, first, second derivative, all that. We are not going to graph every trig function to figure out what the derivative is, but you certainly could. Like, you could figure it out from the graph. We're going to now just list all of them, since you see where they come from. Jane still thinks they're fake, but other than that, you know, there is a reason they're there. Anybody questions on those sketches and what that looks like?
What are we doing?
What are we doing? So you have to know all of your trig derivatives so that then we can use like chain rule and quotient rule and implicit or all of that with trig derivatives. So let's make a lovely list of all of the trig derivatives.
I really hope I'm not on that list. And
All right, guys, I have some more kind of weird notation for you. Because this isn't like a full equation, I don't have like y equals something and then I'm taking the derivative. We're going to write d dx of sine of x. That just means the derivative of sine with respect to x. Okay? I know we don't like all the notation, but we'll get there. We figured that one out. That is just cosine. Okay, so then d dx of cosine, we found that one also, right? There is for, like, we'll do it for tangent and show you where that comes from. It's a little tougher with sine and cosine. Graphically, it's definitely the easier way with those, whereas graphically with tangent is not super easy with the asymptotes and all that. All right, then let's do d dx of tangent. I'll tell you what it is, but then we'll prove it algebraically here in a little bit. That one is secant squared x. Which, again, graphically, that's not something that's going to jump out at you. You don't really know what secant squared looks like, but we can get there algebraically. All right, then let's do the reciprocals. So d dx of cosecant. Negative cosecant cotangent.
So do we even know like in and out? Like
You have to memorize these six. Yeah, you gotta know them. All right, let's do d dx of secant. Any guesses on this one? Something with tangent. It's secant tangent. There's no negative in this one. All right, and then d dx of cotangent. Want to take a guess at that one?
like cosecant squared x.
Negative cosecant squared x, yeah. So when there's a cosecant in the answer, it is negative.
Yeah, one of the ones.
So no these.
Yeah.
But yeah, like,
You need a minute?
stare at them first.
Just want to absorb for a moment.
The last is like the worst.
Right?
Yeah.
You'll be
We
fine.
could have done like
This is
easy
like-
addition,
I
like
can't think of any notes that was.
maybe some multiplication, like reviewing how to do long division, but all less.
Should we do like mad minutes and just race with your multiplication?
Yes.
Can we prove that 2 plus 2 is 4?
Yeah, this is it just gets worse from here.
Are, yeah. I mean, anything that's cosecant or sine in your answer is negative and the others are not. Right? Like negative sine, negative cosecant, cotangent, negative cosecant squared. Like, so anytime that's in the answer, you know there's a negative.
Yeah.
Secant and cosecant both have secant or cosecant in them. Tangent and cotangent are
So no passes.
not really. You just gotta know stuff.
You just gotta know. Like, think of it in your head like in a graph.
I do for sine and cosine, but I don't picture the tangent graph and go, oh, the derivative of that is clearly secant squared. Like, nope, can't visualize that one. But let's do that one algebraically. That's our first example here, guys. Let's find d dx of tangent of x. And not just, oh, we know it's secant squared. Let's show why it's secant squared.
So this is what we do, like,
Yeah, this is like what you'll do. Can we write tangent as something
Secant
else?
squared x.
No.
it's like
Sine over cosine.
Why?
Okay.
What is the difference between d dx and dy? What?
So is this an equation with a y in it?
No.
Okay, so we're not going to use that.
Oh, okay.
It's just like we're taking the derivative of this expression that has an x in it. That's what we're doing this time. So it's a little different. Yes, of this piece, but it's not a derivative of the whole equation this time. All right, so I'm going to say d dx of sine of x over cosine of x. That's where we're going to start. Okay.
Why can you not just turn it into secant squared x?
We're showing why it's secant squared x.
Oh, we can just write it.
Kind of, but not. I'm just showing you where it comes from. Algebra.
Oops. I love it.
Do we see the quotient? Yes. Yeah? Okay. Quotient rule. Do you guys want to try it?
Oh.
No. Okay. Denominator times derivative of the numerator. Well, guys, what's the derivative of sine? Okay. Minus numerator times derivative of the denominator. Well, what's the derivative of cosine?
Oh, I see. Negative sine.
Negative sine. Yeah, it's actually pretty cool how it all clears itself up. Over cosine squared.
And that's
Proof
Wait, cosine squared.
Oh.
I forgot.
Quotient rule? Yeah, denominator squared.
Part.
Yep.
It's gonna go really well for me.
And cosine squared plus sine squared is 1. And what is 1 over cosine squared?
Oh my
45.
Oh, secant squared.
Oh, wow.
Okay, you know what?
That wasn't that bad, right?
Yeah, well, let's make sure it's not It's gonna get a word.
I'm really excited for this lovely train.
She didn't
My
say it
life
was
is
wrong.
It's going
I'm
really
just
well.
laughing at you. All right, next one. Find dy dx. Okay, that means we're probably gonna have a y and like do an equation, right?
Oh, what? No.
Of y equals the cosine of 5x. This is not hard, guys, I promise.
Yeah.
I promise.
What a promise that is.
But again, this is what I'm telling you. In 11, you learned power, product, quotient, chain rule, all of those things. You have to be able to use them in Skill 12. So if you were weak at any of those, they become kind of glaring. All right, so
Wait, this is still 12, right?
this is 12. Yeah.
The last one.
So it's not like this is gonna be a dumpster fire.
No.
Almost, literally. Yeah.
I hope we have no
Wait, so
dumpster
that means
fires.
the studying we do with like 11 kind of goes into 12.
It
as well,
does.
right?
They very
So, like,
much
you can
connect.
honestly like knock out 2
Mhm.
ish. A lot of stuff to do.
Why is there no Y's in this? Like, why?
So those weren't full equations, right? It was just an expression. So like if I gave you, you know,
So you find the
7x cubed plus 5x all to the 9th. And I don't say equals y or anything like that, but I say find the derivative. That means d dx of that thing. Okay? Whereas here I had y equals cosine of 5x, so now I can do dy dx. I know it's like weird details, so I get it. Okay, cosine of 5x. Guys, this is actually a chain rule with your trig derivative. So, what is the derivative of cosine? So we're going to have negative sine of 5x times, what do you think? Times 5. So you could just write negative 5 sine of 5x.
Wait, why is it changing?
Because you work from the outside in. You had to take the derivative of that inside piece of the 5x.
Oh, yeah.
Chain rule before, you might have had like x plus 3 to the 5th. And so you do your power rule. We'll make that a 2x plus 3. And then times the derivative of the inside.
Okay.
That's what we did. We took the derivative of the outside, the cosine part, times the derivative of the inside. Do more.
Oh,
That's it.
Oh, I see.
Oh, it's it?
Yeah, we're done with number
I
2.
kind of forgot.
And we have 7 examples today, guys. Just so we're including those 2. We're already on number 3. Okay, same directions. Find dy dx. You guys try this one, okay?
Wait. Is this also fine dy over here?
Yep.
It's, you know what? Mine's now 4 left.
Why is what?
So I think it's 4 instead of the outside.
Why is there no 4 at the top?
Like with X,
Just goes on X.
with a 5 X. Like whenever there's a like there's a 5.
That's not to the 5th. That's like times the 5th.
Oh. Where's the dash going from again?
Derivative of the inside. So what's the derivative of 5x?
Oh, it's 5.
You see it? Nate?
Yeah.
Okay, so we took the derivative of cosine of the thing, right? That got me negative sine of said thing. 5x is still there. No, it's cosine of 5x. So that's like the inside of your parentheses. Then you have to take the derivative of the inside. So what's the derivative of 5x?
Oh, wait.
That's where that 5x.
So it's like the sine, the cosine is like
It's still
Yeah. And we were actually doing that up above, but the derivative of the inside for like all of these, because what's the derivative of x? 1. So I was just taking it times 1 so we don't write anything. But technically you're still doing that. Okay. We'll keep trying. You guys okay? We got it? All right, guys. So start on the outside, work your way in. Derivative of sine is cosine. Leave the inside alone. Then multiply that by the derivative of the inside. So what's the derivative of the inside? 6x. So you can leave it like that, or you could say
Thank you. I was thinking for the
6x cosine of 3x squared. Okay.
So do you put the dy every single time?
If you have a bunch of steps, no, but put it in your answer. That's fine.
So better because I thought that other one.
Calculus, they might be meaner to you, but
Yeah.
6 cosine 3x cubed.
Also, like on the outside or
no, because it's not the cosine. Think like when you had a graph. If I had like 3 sine of x, that meant vertical stretch by 3. That was different than sine of 3x, which was up here. Okay. It's just like if you had like that, you can't distribute this 3 when there's a power out there. All right, let's try again. We're already on number 4, guys.
Wait, for the cumulative, is that going to also be its own grade in the grade book?
No. Well, okay, part 3 cumulative, yes. Full year.
Full year, sorry.
Nope.
So we can
is-
bump parts that we did really well on.
It's just 1 grade. It's not 12 different grades.
Wait.
So we have to do like get it out of the whole thing.
To get an A. Yes.
Wait.
Oh.
Wait. So if I got an A on the whole thing, would it overwrite all of my other
It replaces 1.
one?
Yeah.
Not everything?
No, because it's not as in-depth as each individual skill exam is.
That'd be crazy because you could have an F in the class and get an A on the last assessment. But you can have an A. That'd be crazy.
Yeah, we're not doing that, no.
Oh,
Yeah, it replaces like add like that.
Wait, you just delayed for this degree time?
Wait, that's tragic.
Yes. Guys, look at this one. Do you see how it is product rule?
Nope.
Now you see.
I saw that. That's why I was.
Oh, okay. Strong emotional response. How's it going, Anna? You look sleepy.
There's 21 days of school left. That's
2 days.
Oh, I love having 2 days of school left.
I'm like looking 22.
Remember, 5 of those are half days, though. So that's only 16 real days.
And the last
I have to use like
What do you mean? You have to use the product rule and the chain rule. Oh, you don't have to do that. Yeah. You can, but you don't have to. 180.
So that means like 70 something black days.
Yep.
Let's go.
You've had almost 80 black days this year so far.
It's a lot of quality time together.
Only 80? Why can't we just have black day every day?
Support that, yes.
I can eat red things.
Like, I lead educational class
Not glad that you don't enjoy the others.
Oh, you also got 5 days. Oh, yeah, you get a little bit.
All right, guys, let's look at it.
I had a
Did we get 9x squared? Sine of 2x plus 6x cubed cosine of 2x.
Wait, why isn't it minus?
Because it's product rule.
But isn't it negative, like isn't it negative cosine when you take the...
Derivative of sine is cosine, but derivative of cosine is negative sine. Finn?
Why is why there's 2 there? Is it because you do that? Do you do the chain rule for anything where it's like 4 and then sine of x? There's like a 2 or
Probably.
Is it the last one?
Will probably be a mountain climber quizzes.
The last?
I don't know. We might do one. We got a billion review days. I do more quizzes.
I was gonna help. Actually, no, I wasn't gonna help.
This is not hard, guys. This is easy.
What is that? It's the late. What is calculus.
Y plus y
You
to the fourth.
enjoy
So is that?
you enjoy math class.
I said y plus y.
Yeah, I like math always, so.
I mean, it's kind of I saw your
Second derivative.
I thought that was fair.
Oh. Yeah, ready, go. Guys, there's not even like chain or product or anything. It is just
I'm gonna change.
tell me the derivatives. And then add those two together.
But how do you add?
You'll see.
Then you put the cup on
I
there.
think it's like
So it's blinking. So 8.
Yes. You add the two. You add the.
being called.
You're gonna add the one that you got from the double derivative, and then
Put a cup there next to you. Is that one? Was that already in there? This is carbon.
Yeah.
There you go.
It's brewing. This will be a fun experience for you.
I mean, I've had coffee before. This isn't my first time drinking coffee.
Be careful, man. I think you should. So then you gotta find the derivative of this.
Second derivative.
Negative.
You can do it. Not y to the 11th. Y double prime. Oh my gosh, y to the 11th. That would be a doozy. Wow.
What a doozy.
She hates us. No,
Yeah.
Wait, I just got. Wait, I think I'm doing this.
I'm not really sure what.
Oh, is that actually it? Oh, okay.
Mr. Lee, I got kind of a non-existent answer.
Yeah, you might be onto something.
Okay.
You know, that was just cool.
I kind of just got 0. I kind of just got absolutely no answer.
I edged a little bit.
So,
Plug and tug, baby. Plug and tug.
It's not actually hard. This one is not hard at all.
Black coffee, fair enough.
Ooh.
Like you take the jolt.
You're wrong. You're wrong, morning.
You're a black coffee kind of guy?
I normally am.
last time I drank coffee, I was like 10 years old.
Okay.
Oh boy.
I thought it'd be edgy, so
I'm sorry.
I don't know. And then I stopped because I was like, this is
Too edgy.
It was
All right, guys, let's look. All right, guys, what is the first derivative?
Oh, the fact that I missed is actually true.
Okay. What is the second derivative?
Oh no, it definitely is not. Oh, not off that section. Look, that's why I can't.
Oh yeah, this one's sine. Sorry.
Hold on. Let me make a little conversation.
All right, minus 3 cosine of x.
We're never done.
So when you add y and y double prime, what do you get?
Oh,
Zero.
yo, come on now.
Two left, guys.
Okay, you can come in.
One way, I'm making it out of control.
No, I can just see how you want it.
It has exponents.
Do you see it, Maddie?
Oh, you just use the first derivative to get to the.
Yeah, that's why I found it. All right, guys. Again, find dy dx here.
Oh, I see.
Careful with this one. It's chain rule, but you actually have an exponent on your sine function as well. So think about it.
I don't know how to think about it.
I can't think.
Yes, you can. You can do it, guys.
You're going sick. Alright.
You do know.
Caesar, boy.
What, Nate?
Yeah, boy.
So if I have,
To the third.
what do I do there? That's a start.
Okay, I'm just gonna pretend that you can put the
Real-
three outside the entire.
This is how another way you could think of writing this.
Oh, I bet. Yeah. Cool. That's a lot better.
Does that help you?
Yeah. Wait. Yeah.
There's a lot happening here with your chain. Start on the outside and work your way in.
chain rule also we did
Yeah.
Oh, wait.
we did it and we
That's what I did.
where is your
Wait, there's no H. I really just want to
Yeah.
Why is there like
write it up here.
on the outside now?
That is what it means for sine cubed of 2x to the fourth. It means sine of 2x to the fourth 3 times. But I think that's easier to see chain rule from than the way it's initially written.
Stop.
So guys, it's like a 3-part chain rule thing. Like you're gonna have a lot of pieces.
So basically, you got like an exponent by the sine. You put it outside everything.
So easy. You told me nothing.
No. I think I got it, but like I was joking.
It's just one step at a time. Work your way in.
It's a.
Start with the 3 on the outside. Then deal with the sine. Then deal with the 2x to the 4th. 3 pieces.
I had to find that association this way.
Raised to 2x.
The derivative of that.
Sine is not raised to 2x to the 4th. Let me show you your first piece, starting on the outside, working in. The first one, okay. When you do the 3, everything stays the same in here. Square.
Yeah, so first
That's step 1. Okay.
I thought it's the 3.
Then we move into the inside. So we're done with the exponent outside. Now we're looking at just sine of 2x to the 4th. So what's the derivative of sine? Cosine of 2x to the 4th. Then all the way inside, what's the derivative of 2x to the 4th?
That's really not hard.
Actually, when I did
I see outside. So then I can just simplify a little bit. What do I get? 24x cubed. But then we're not, you can rewrite this as like sine squared of 2x to the 4th if you want. But it does not matter. Times cosine of 2x to the 4th. All right, let's stop there for a second. Do we see it?
Yes, we do. I don't know if even yes.
Yes.
Yes. That's what I got.
Yes. What's the derivative of 2x to the 4th?
Is it the double chain rule?
I mean, it's just
the chain rule of the.
you must do every chain of your chain rule.
A lot of chain rules.
Oh,
Nate, do you see it?
Yeah. I'm just signing.
So you were good with, like, you're good with this piece, right?
Yeah, and then the next one. But then the last
Oh, the last one that's all? Okay. What's the derivative of this inside piece?
is but like
You got to get all the way to the inside part. Start on the outside. That happened here. So this is here, we subtract one, we got this. Now we look just at the inside. So we're working our way in. The derivative of that is here. Then we look just at the inside here.
so those two, like right turns, those are the derivative of this. So it's not like you have to change all twice.
It just all is the yeah, you just keep working your way.
I read that essay 3 times. There's no way.
If you had like 5 parentheses things in there, you would
Ignore the square, like.
Yeah, because we've done that.
Already done.
You sort of rewrite this and then work with this piece.
Yeah.
And then you rewrite that and then you're done. Okay?
Awesome.
All right. Guys, one more.
I hate this. I literally had so much time to put everything up beside this. I still got all the oil on it. Speed up the
It's not something. That's right. They're
Whoa, pause.
This is what coffee does to you? I don't know.
No, I thought that's what she said.
no.
Also, I haven't drank any.
Oh, that's second.
Oh, come on.
Oh my, I don't.
Oh,
Isn't that like the second derivative?
that is the second derivative. It's the second derivative of y with respect to x. I know it's weird, but that's the proper notation. All right, guys, ready, go. You can do it.
You know, I personally beg to differ, but glad somebody believes.
Dotlet.
Okay, kindly what do
I mean, step one is find the first derivative, right? So start there.
Let's do that.
You do not have to use the product rule because it's not 4 and a variable times cosine. It's just a leading coefficient. It is essentially chain rule because it's 1/6 x. Well, what's the derivative of 1/6 x? There you go. So it's like baby chain rule.
What is going on here?
I see the issue here.
You
What
too.
is this? Why? This isn't right. Just crisis, what is that? We won't say track, so yay.
Minus. Minus that.
Oh, that's stupid.
All right.
Let's make sure we've got our first derivative right.
What is going on? It doesn't make sense. I'm so stupid. Wait. Never mind, I'm right. I'll just type myself out.
Everybody okay with the first derivative?
Yeah.
Yeah, and then second derivative, we just keep going. Not negative. There we go.
Why is it on
What? Oh. Is this the?
Yeah.
So what do we get? -1/9
Yep.
cosine of x over 6.
Yeah, we did it.
Yes, it's still in.
Ah. Oh, and I forgot my second derivative business here.
Okay, that's not too bad.
There we
I
go.
got confused.
Whew, okay.
Oh,
All right.
So then you gotta just get the derivative.
Shit. We okay? It's pretty procedural, right? Like,
It was great.
okay, good.
I died.
You didn't die. Excellent. That's a win, right? No math class deaths today. We're good.
like Do you think so?
Sometimes you want to die, so. It wasn't the you saw, it was the method we used along the way.
You got there.
Well, can I borrow your charger?
I walk in there and I get first.
Wow, it's like breezy in here today.
I mean, it's like closer to.
Okay, guys, we are doing a quizzes.
There is so much like stuff in my
Absolutely. I'm not even lying. I'm not even joking. However, what about it? Every time
Sorry, guys, I'm trying to find one I like.
I will not be joking. It is a first. That's why I like it.
I'm super rusty.
I joke.
Still looks nice to everybody. Now, okay, I'll be busy. Because for me, if I had the. That's why you.
Guys, let me say